Jai Hind. My name is Dr. Ayushi Prakash and I am working as professor in Department of Computer Science and Engineering. So today the lecture topic is transaction and the subject is database management system. It is very important to discuss about transaction because when we are knowing about the database, when we are able to create the database and we are able to normalize the database, now the most important thing for any database is transaction. So what is transaction? You can say transaction is like any single logical unit of work. If we are doing, we can say yes, it is this transaction. Like if we want to know the amount of money that is in our account, then we are reading the data, and that is one transaction. If we are crediting the data amount, some amount, like we are crediting an X amount from our account, then it is a transaction. Again, we are debiting our account from with some amount, then we can say again we are doing some transaction. So if we are doing any single logical unit of work, we can say yes, it is transaction. So the very important thing we have to know about the transaction and how can we ensure the transaction in integrated. I mean, like if a transaction is going in any database or in any type of tools, then the transaction should be consistent. The transactions should preserve them some rules. So like we can see everything in this, we will be discussing in this PPT. So first of all, what is transaction? A unit of program execution that accesses and possibly update various data items, right? So accesses, I mean like reading the amount, and update, I mean like writing. So what is this reading and writing? So when we are talking about any transaction, so we are knowing now what is transaction, that any single logical unit of work. If we are doing any unit of work, we can say yes, it is transaction. Now the two important operation, if any transaction is executing, the two important operations are read operations and write operation. So what is this read operation and write operation? When we are talking about read operation, we can see here it is mentioned read operation, right? So when we are saying read A, it means we wanted to know the amount of A. So from the database, we are taking this value into the local buffer by the operation read, right? And when we want to update this value after doing some, after adding some or subtracting, addition or subtraction or any updation, we want to update by a write operation. So what this write operation do? Again, from local buffer to the database. It is saving the data from, it is transferring the data from local buffer to the database. So these are only two operations in any transactions, any number of transactions. These are only two operations that we can do while we are talking about transactions. So here, if we want to understand the transaction, we can take an example. Let's suppose read A. It means let's suppose it is transaction T1. If we are naming it as a transaction T1, what happens here? We are reading A. I mean like a read operation on account A, on data A. So reading means we are now getting the value from the database. Let's suppose the amount of A is here is 200. Now A is equal to A minus 50. This step means now we have to deduct the value 200 by 200 minus 50. Now the value will be 150. So this value will be in local buffer. Now when we want to save it in the database, when we want to update the value, we have to do write B. And by write B, this value, earlier this was A was 200, now the value of A is 150. Again, we are going to read the value of B. Let's suppose the B value was 300, right? Now we have to add this 50 here 300 plus 50, that is equal to 350. So now we again have to write the, yani updating the value of B. Now we have to update the value by 350. So we can see here earlier the value was 200 and A, and value of B was 300. Now after this transaction, the value of A is 150 and the value of B is 350. Now coming to the, so there are so many, when we are talking about transaction, there are so many issues that we will deal with. I believe transaction and the two operation is clear now. So we are coming with the issues because we are understanding about transaction. We are working on transaction now. We are able to work on transaction. The next problem is what are the different issues? The very first issue is anytime due to any types of failure like network failure, hardware failure, system crash, any type of failure, failures of various kind can create some issues with these transactions. Now coming to the next point, that is concurrent execution of multiple transactions. So these 2 points, how can it be creating, how can we say that it can create the problem? We can see here. So if any time this 50 rupees deducted and due to network issue and it is not updated in the database, so it will create that the money, it will create a problem that the money has already been deducted from here, but it is not updated over here. So it will create some problem. So this is why we can say that the failure of various kinds, such as hardware failure, system failure, network failure, will create some issues. Now concurrent execution. So if any transaction executing at a single moment, then it is okay. But what if there are two or more than two transactions at the similar time wants to access this account A? So this will create some problem because each and every transactions wants to execute in an isolation environment so that the consistency should be maintained. Consistency means, let's suppose here before transaction, the data A plus B was 200 plus 300. A was 200 and B was 300. So the data is 500. Now, when we are doing these transactions, now updated value we can see A is 150 and B is 350. Now, when we can see here A plus B 150 plus 350, that is 500 again. So before transaction it was 500 and after credit and debit it is 500. So we can say that yes, the consistency is maintained here in this transaction. So if we are executing in a single environment, then it is very easy to maintain the consistency. But when we are working where two or more than transactions working together at a particular moment, so this situation is called concurrent execution. This will create some issues in the transaction and the consistency of transaction. This may create some problem. Now, coming to the asset property. So why we are talking about asset property? Every time when we are going to read any topic, we should know why it is important. It is important because to preserve the, we can see here, to preserve the integrity of data, we need to know about these properties, and any database, if we are saying that yes, it is a good database management system, then that database has to follow all these properties. Like so, if any transaction, a single unit of works, either read, access, or updation, so in that particular transaction, it has to follow the all these properties so that it can preserve the integrity. So what these properties are, basically we can discuss about atomicity. Atomicity says that all operation, either all operation of the transaction are properly reflected in the database or none. Let's suppose in this here, we can see here that suppose that if we have deducted this 50 amount from 200 and now at any point we are seeing that this is not happening due to any failure, database, like network failure or any type of failure, this is not updated. So in that case, if we are not updating this A account, the value will reflect 200 again, because we are doing this in the local buffer, but after updating it, it will be going into the database. So now if this step, step number 3, we are not able to do it, then what we have to do, atomicity property is saying if any occur happens in any point, then in that case, either all operations, suppose that this operation doesn't happen rightly, so we have to restart from here. So if at any point, at any operation, we are facing some issues, then we have to restart it from the start one, either all operation or none. So this is what we call atomicity. Now coming to the next, that is consistency. We have already discussed here the consistency. So consistency, what the consistency is, execution of transaction in isolation preserves the consistency of the database. So we can see here, before transaction happened, the value of A plus B was 500, and after transaction, the value will again the value we have seen here again 500. So we can say that yes, the transaction is following the consistency rule. So execution of transaction, it happens, it assumes like it happens in isolation. That is why they preserves the consistency. Now coming to the next, that is isolation. Although multiple transactions may execute concurrently, each transaction must be aware of other transaction. Executing transaction, intermediate transaction results must be hidden from other concurrently executed transaction. This is the biggest problem what we have to discuss in this transaction, when concurrent multiple transactions executing at a similar time. So it is the requirement. So we have to do multiple transaction at a particular time, but we have to do these transaction in a way, in an environment, so that each transaction should feel like that transaction is working in isolation. So we can see here, multiple transaction may execute concurrently, but they should unaware of other concurrent executing transaction. ये कैसे हो सकता है? ये तब हो सकता है when we are providing all the required resources to the particular transaction in a particular time when it is required. So it feels like if resources are available, it means that these transactions working in a isolation environment. Durability is also important, that we have seen this problem. Any type of failure, and we are losing any data from the database. So durability is important, because although we are facing many type of problems, many types of failures, but still, if any database, if any transaction is showing durability, it means it is showing the data, it is showing again the data after any type of failures. So after transaction completes successfully, the changes it has made to the database persist even if there are different type of system failures. So now we are knowing about the transaction, the operations of the transactions, example of transactions, and the different properties, ACID property, ACID property, that a transaction has to follow these properties to be a good transaction. And now come to the next important topic, that is a transaction state. So if any transaction, if a single transaction I am talking about, so if a single transaction executes in different states, right? So when it is, so you can see here in the diagram, right? It is the first step, that is active state. So when we can say it is an active state, right? When we can say it is in, the transaction now it is in partially committed state. When we can say it is in failed, it should be aborted, it is in committed state. So these are the 5 states of any transaction can happen, right? So when we are saying that a transaction is in active mode, so there we want to say the initial state. Active state is the initial state of any transaction. The transaction stays in the state while it is executing. When the transaction is executing mode, we can say this is the initial state when the transaction is in its executing state, and this is what we call active state. Now, when it is an active state, it must be go somewhere after the completion of the execution. So when we are executing the last statement of the transaction, then we can say, yes, it is partially committed, but it is not committed. It is not saved in the database. We have done the last statement of any transaction, last operation of a transaction, but it is not saved yet. So we can say after the final statement has been executed, we can say it is in partial committed state, but it is not committed yet. So the another state, committed, when it is successfully committed, when it is successfully committed, it means it is updating the value of the database. Then we can say, yes, it is committed. No chance of failures can be seen here, right? So fail is after the discovery that normal execution can no longer proceed. So we can say if any transaction now it cannot be longer in the normal execution, so it has to be failed, right? So we can see here when a transaction in its active state, it can go from active to partially committed, means the final statement execution, or it will be going to the fail state directly, means it is not able to do the final operation, final statement of transaction. But before that, because we are seeing either all or none, so before that any problem occurs, and in that case it has to be failed. What happens when the active state transaction goes into the partial committed? Yes, when it is in the partial committed state, there are two chances. Either this can commit the transaction by saving the database, by committing this database can be updated, or before the updation of the database, it can be failed. So these two chances can happen after the partially committed. But when it is committed, there is no chance of failed. When we are saying a transaction is committed, means a transaction has saved the value, updated value into the database, then there is no chance of fail. When due to any case from active or from partially committed, any transaction is failed, then we can say now what we have to do, we have to abort the transaction and roll back to the safety state, and again it has to start in the active state. So now it is very clear that these are the 5 states of the transaction. The initial state is the active state when the transaction is in execution. When it comes to the final statement execution, we can say yes, it is finally partially committed, but it is not updated in the database. When we are able to update the database, we can say now it is committed. And when partially committed change into fail due to some type of error, then we can say now it is fail, and now what state we have to do it? We have to abort it and roll back it to the safety state, and we have to restart it. So these are basically we can say these are the 5 states of transactions, right? I believe it is clear. Now schedule. When we are talking about transactions or multiple transactions, so there must be a word. Suppose that if in our college there are so many classes, there are so many faculties, so there are so many classes executing together at a particular time. So let's suppose it starts from 8:30 to 9:20. So there are so many classes, first year class, second year, then there are so many sections. So how it has happened? Have we ever thought about this, that how all these classes are occurring at a similar time? Just because we can order them, right? Which available faculty can be scheduled to which available class where it is required. So here faculty can be taken as resource and the classes can be taken as process. So if any process has to be happen, then it requires some resource like some faculty. So we can schedule it. Earlier we can schedule it where we can better utilize all the resources. So schedule is what? A sequence of instructions that specify the chronological order or the order in which the instructions of concurrent transactions are executed. So we should know in which order it has to be happened. So this is what we call schedule. So sequence of instruction that specifies the order in which instructions of concurrent transaction will execute. Transactions are scheduled. A schedule for a set of transaction must consist of all instructions of those transactions, must preserve the order in which the instructions appear in each individual transactions. So it has to preserve the order in which the instructions appears in each individual transaction. Let's suppose if it is not following the order, so what we can do, we can read without. So if the order is write A and then read A. So let's suppose here write the updated value of A is 500, and before doing this, if we are going to read the A amount, so this A can show the earlier value of A. Like, let's suppose we can understand here. We can see here. So this was the order where we have to read the account A. So if we are reading the value of account A and then updating by minus 50 from the account A and then writing the value. So if we are not following the order, in that case, without seeing this value, now if we want to do this right B, so this can't be happen because this value that is debited from here have to credited here, right? So this is the order by which we have to do the execution. If we are not following the order, then the transaction can be failed due to some error, right? So we must preserve the order. Let's say, here we are taking an example of transaction and we are naming it as a T1, right? So we are making a schedule here. So the another is T2. So we are taking here two transactions, T1 and T2. When we are working on a concurrent execution, we need to make a schedule for that, right? So let's suppose when we are creating two transactions, T1 and T2. So what we have to do here, we are going to make the schedule. Let's suppose the schedule is S, right? And this schedule S is serial. Why it is serial? What is non-serial and what is serial? We will be discussing here. So transaction T1 and transaction T2 are two different transactions in this serial schedule. What we have to do this in the serial schedule, we have to do T1 is followed by T2. T1 is followed by T2. Who will follow? T2 will follow the T1. It means it is serial. Serial says that one transaction will work after the completion of the first transaction, another transaction. So if I am saying T2 will follow the T1, it means after the completion of T1, T2 can start. In between, T2 cannot start, right? And we can see here what we have to do, transfer of 10% of the balance from A to B. So this is the transaction. So in transaction A, what we are seeing, in transaction T1, we are reading the account A, means read operation. Then we are updating the value A minus 5, debiting the value by 50. Then we are reading the account B and crediting this 50 to this account B, and then updating and then committed. It means the value is permanently saved. Now it is the final state, committed state. Now, when it is committed, then again T2 starting here from reading A value, and then we are creating a buffer, a local value in which we are saying that 10% of A. So A is equal to A minus 10. Temp में आपने क्या value डाली थी? 10% of A. So we are deducting the temp value from A, and the updated value will be updated in A. So we can update here and then commit the value, we can say, after adding this temp value to this B. So this is what we call serial schedule. And again, we see again the same, where T1 is followed by T2, right? So we can see here that these are the serial schedule in which one transaction happens, and then after the completion of the first transaction, the second can happen. And this can be happen like T1 can start earlier and then T2 is following the T1, or T2 can start first and then T1 will follow the T2. So for this class, this is more than enough. In next class, we will be starting this from here only. Thank you so much.